All right. So we're going to cover 5, 3, 5, 4, and 5, 5. To start with 5, 3. Got to introduce some vocabulary. So we're going to be talking about all three of these sections. We're going to be discussing these things called polynomials. A polynomial is a combination of terms. So this is an example of a polynomial. Okay, each of these is a term. A term is therefore some combination of coefficients and variables and exponents, okay, by multiplication. Addition or subtraction is what separates one term from another. So if there's a plus, that's kind of what separates a term. As long as you're just multiplying, you can have a term with multiple variables. Or you can have a term with just a variable, or you can have a term of just a constant. But that plus is what separates your terms, or a minus. I guess I should have done one of these as a minus just so it'd be something different. So minus is the same because minus is the same thing as saying plus and negative or whatever. So again, each of these are terms. And then any collection of terms is a polynomial. Okay, if you have two terms, that is called a binomial. If you have three terms, that is a trinomial. And anything else is just expressed as a polynomial. Sorry, I'm trying to get this out of the way of the screen there. So a polynomial is multiple terms. Terms is any combination of coefficients and variables and exponents separated by a plus. Again, the plus is what divides your individual terms. A term can have multiple variables or just variables, no coefficient, because technically this has a coefficient of 1. Same thing, your exponent is 1. Or no variables. That's like having a variable with an exponent of 0. Then that's a 1 and you don't see it. So anyway. Okay, they're going to ask you a couple of the problems in your homework is going to ask you to identify, is this a binomial or a trinomial? I guess technically, I didn't say, but if there's only one term, that is a monomial. So one term is a monomial, two terms, so it's two terms is a binomial, three terms is a trinomial. Anything more than that, and it's just referred to as a polynomial. These two are also polynomials, they just have a specific name. So there's a couple of definition things in there. It'll ask you to identify. Okay, so again, if there's just two terms, this would be a binomial. Three terms like these would be trinomials. More than that is just polynomial. If it has 4 terms, 5 terms, 6 terms, whatever. Okay, another definition is there is a thing called a degree. The degree of a term is the sum of the exponents of the variables. Okay, so coefficients and exponents don't really matter. It's just the exponents of the variables. And remember, if you don't see an exponent, it's a 1. So this term would have a degree of 3 because you've got an x to the second power and you've got a y to the first power. The sum of those 2 plus 1 is 3. This term, so when you can't see the exponent, it's a 1. So this would have a degree of 1. We kind of scroll up the paper here. So this first one that I gave you, or one of these first ones, so 5, x to the third, y to the second, z would have a degree of 3 plus 2 plus 1. So that would have a degree of 6. This would have a degree of 1. This would have a degree of 0. So again, it's the sum of the exponents of the variables. Okay, so again, the degree is the sum of the exponents of the variables. So this one would have a degree of 2, this one would have a degree of 1, this one would have a degree of 0. Each term of a polynomial will have a degree. You can also have the degree of the polynomial. And the degree of the polynomial is just the biggest degree within the terms. So, got kind of a mess going on here. I'm going to switch over. We'll just do some examples. So if I gave you some polynomials like 5x y cubed plus 3x y z squared plus 2 minus 4x or some kind of nonsense like this. Okay, again, we've got 4 terms, so this is just called a polynomial. The degree of each term is again the sum of the exponents. If you don't see an exponent, it's a 1. So for all of these variables with no exponents, you can see that they have a degree or an exponent of 1. So this term has a degree of 4. This term also has a degree of 4. This term has a degree of 0, no variables, no exponents. This term has a degree of 1. So the degree of the whole polynomial is 4. It's either of those because they are both technically the biggest individual degree. So again, identifying this is just referred to as a polynomial with a degree of 4. We did something like this. This has 2 terms, so this would be a binomial with a degree of 1. This one has a degree of 1, this one has a degree of 0. So there's a couple of problems built into your homework where they're just going to ask you to identify binomial, trinomial, okay, and then what is the degree? So you can find the degree of each individual term. The degree of the whole polynomial is the biggest of those degrees. And remember, for any variable where you don't see the exponent, it is automatically a 1. So don't forget that. All right, now the bulk of 5(3) is combining polynomials by operations. And it's just going to be addition and subtraction. So the bulk of 5(3) is about adding and subtracting polynomials. And the big take-home point is you can only combine like terms. That's it. Like terms have the exact same variables to the exact same exponents. There's not a whole lot of things they can do to make this tricky. They're going to start off relatively simple. They're going to try and get more complicated, but as you're going to see, it's really not anything too difficult. So if we were looking at some examples, they're going to start off relatively simple, like okay, x squared plus 3x plus 7 plus 2x squared minus 2x minus 3. Okay, again, you're going to be combining by either addition or subtraction. And again, you can only combine like terms. So if we're going to add these things together, you can only add the things that are the same. Okay, so for example, we've got an x squared, which is like saying 1x squared, and we've got a 2x squared. These have the same variables to the same exponent. So if I combine those, 1x squared plus 2x squared, that would be 3x squared. Like Otherwise, I've got a 3x and I've got a negative 2x. If I combine those 3x and a negative 2x, I get 1x. And I've got a positive 7 and I've got a negative 3. I can combine those. 7 plus negative 3 is 4. So this is my combined polynomial. So again, in combining, you just combine like terms. When you do that, notice your terms don't change. X squared, stayed x squared. It's almost like that's kind of like the defining thing. If we've got 1 Red Sox and 2 Red Sox, we've got 3 Red Sox. Okay, so the x squared didn't change. We just added the big numbers in front, the coefficients. Same, 3x plus negative 2x, 3 plus negative 2 is 1. Term, the x didn't change. Constants, same. The only thing they can really do to kind of make this tricky is throw in way more variables and do something like this. So if you have trouble reading, that says 2x to the second y minus 3xy plus 4xy to the second plus 2xy to the second minus 3x to the second y minus xy. So again, what makes this tricky is we've got x and y's kind of all over the place. But again, pay attention, like terms have the exact same variables to the exact same exponents. So while this one has an x to the second and a y to the first, you'll see this one has an x to the first and a y to the second. So here they flip the order around a little bit. Here is our x to the first and y to the second. Here's x to the second and y. Here's x and y. So, okay, none of these are like. They all look similar because you're just dealing with x and y's, but the squareds or the lack of a squared is kind of what makes those different. So if I'm combining, again, pay attention to and make sure you're combining like terms. So an x to the second y can only combine with an x to the second y. So if we combine those, 2x squared y plus negative 3x squared y, that would be a negative 1x squared y. Go a little darker. Same, my xy's can only combine with my xy's. So negative 3xy plus negative 1xy is a negative 4xy. And then finally my xy to the seconds. So 4xy to the second plus 2xy to the second would be 6xy to the second. So you can only combine like terms. Now, like I said, there's not a whole lot they can do to make this tricky, but they're going to try some other stuff too. They may give you more terms. They will also throw in subtraction. So the only wrinkle subtraction adds is, remember with subtraction, that's the same as saying plus the opposite or adding the opposite. So we're going to go ahead and do that. So when you have a negative out in front of a polynomial, you distribute that negative. So this becomes adding a negative 4 and a negative 2. From there again, combine like terms, make sure you're combining stuff that is the same. So 2x plus negative 4x is negative 2x. 7y plus negative 1y is 6y. And then positive 3 plus negative 2 is a positive 1. Now, they're going to do lots of different variables. They're going to use A's and B's and X and Y's and W's and S's and R's. So pay attention to that. Make sure you're only combining the things that you can combine. And regardless of how many terms they give you to add, the only thing you can put together is the stuff that has the same variable to the exact same exponent. So like I said, while all these have x and y's, this is the only x to the second y. This is the only xy, this is the only x y to the second. So you can only combine those things that are the same, and they don't necessarily have to be in the right order. And there's no magic order to write the answer in. You just need to have all of the correct terms. All right, the last thing that they will try to do within this section is they just make the problem look a little different. So if they give you something in function notation, so say f of x equals x squared plus 2x plus 1. Say g of x equals x cubed minus x squared. They may give you something like this. They'll say f of x plus g of x. What they want you to do is they want you to add this thing and this thing. So we're taking x squared plus 2x plus 1 plus x to the third minus x squared. So again, you can only combine your like terms. So we can combine our x to the seconds, x squared minus x squared. If you had one of these and you took one away, you've got 0 x squareds. So those basically cancel each other out. And none of these other things are like it or combined. So we're left with an x to the third, we're left with a 2x, and we're left with a 1. Now that x squared, technically you could write that as 0x squareds, but there's no need to write all of the stuff that you don't have, just like we don't have any a's and we don't have any z's. You don't write the stuff you don't have, so none of this is necessary. We only pay attention to the stuff that we actually have. So anyway, and I did not have to put the x to the third in front. Typically, I put the biggest degree to the front, but it doesn't matter. If you had 2x plus 1 plus x to the third, that's the same thing. Order does not matter. And same thing, they could tell you to subtract. So if they said something like g of x minus f of x. Okay, g of x was this one, the x cubed minus x squared, minus f of x was this one, x squared plus 2x plus 1. And again, the only wrinkle to subtraction is you got to distribute that negative. So this becomes a plus, and then all of these change signs. So again, we've got an x to the third, doesn't combine with anything. We've got a negative x to the second and another negative x to the second. So that would be negative 2 x to the seconds. We've got a negative 2x and we've got a negative 1. So that's basically 5-3. So 5-3 is going to do some of that definition stuff with binomials and trinomials, and then what's the degree? And then the bulk of the questions are going to be just combining like terms by addition and subtraction. Very simple, simply add or subtract the numbers in front, keep the terms as they are. Which really confuses with 5-4. So 5-4, completely different section, different types of problems. 5-4, you are going to be multiplying polynomials. Now, in my math lab, it's really simple because 5-3 is all addition, subtraction. 5-4 is all multiplication. On your test, they're going to be kind of mixed up, and you can see how the problems are going to look really similar. However, the steps in the process is quite different. So I'll just pick a simple one. We'll do that. So 3x plus 4 plus 2x plus 1. So again, if we are adding, you can only combine like terms. So 3x plus 2x is 5x, 4 plus 1 is 5. Really easy. Multiplying. Anytime you are multiplying quantities, you have to do distribution. Okay. You have to multiply everything in this quantity times everything in this quantity. So with addition, you only combine the like terms and that's it. With multiplication, you multiply everything. So we've got to multiply 3x and 2x. We've got to multiply 3x and 1. We've got to multiply 4 and 2x. And we've got to multiply 4 and 1. So when you multiply, you have to multiply everything. That's how distribution works. That's how multiplication works. And the only difference is the symbol. So here you've got a plus. Here's implied multiplication. These two problems look the same, but obviously the process to solve very, very, very different. So pay attention to whether or not you are multiplying or adding. So again, when we multiply, kind of the rules for multiplication is you multiply the coefficient. So 3x times 2x is going to be 6. And then when you multiply variables and exponents, you add the exponent. So x to the first times x to the first is an x to the second. Okay, 3x times 1, you multiply the coefficients. 3 times 1 is 3. And then we've got an x. Same, 4 times 2x is 8x. 4 times 1 is 4. And if we have any like terms, we got to combine those, like a 3x and an 8x. So finally, we get our answer. Very different from addition. So again, same binomials, 3x plus 4 and 2x plus 1. Adding, simple, just combine the like terms, 5x plus 5. Multiplying, little less simple. Okay, a lot more stuff going on. So don't confuse those two operations. Like I said, quite different. Okay, we'll do some more examples. And like I said, they're going to start off more simple and then just get more complicated kind of as you go. So the first problems start out kind of like this. And they'll just give you one term times some polynomial. Again, with multiplication, you still have to do distribution. Just in this case, we've only got one thing to multiply, and it multiplies to each term. So again, multiply the coefficients. 3 times 2 is 6. Then you add the exponents of the same variable. So x times x is x to the second. And we've still got a y, which doesn't have anything to combine with. So it's that. So 3xy times 2x is 6x to the second y. 3xy times 3y would be 9xy to the second. And then 3xy times negative 4xy would be negative 12x to the second y to the second. And again, it looks like and it feels like I should be able to do something to put those things together, but they're not the same. This has just an x to the second and a y. This has an x and a y to the second. This has an x to the second and a y to the second. So none of those have the same variable exponent combination. They look like they should, but they don't. Can't put those together. Those stay separate. Again, just the way they're going to get more complicated is they're going to give you more variables and exponents, or they're going to give you more terms. They could do something like this. Now, again, pay attention. We distribute based off of pluses and minuses. Remember how I said last section, okay? The pluses and the minuses, what separates one term from another. If there are no pluses or minuses anywhere, this is one term and this is one term. So the only thing I've got to multiply is this term to this term. So while there's a bunch of numbers and variables all over the place, because there's no pluses or minuses really anywhere, you've got one term times another. So if we multiply this, 3 times -2 is -6. And then that x squared times x is x to the third. Because again, if you don't see the exponent, it's a 1. Add those together. Y to the third times y to the second is y to the fifth. And z times z to the second is z to the third. Now, in my mind, the hardest problems of these is when they give you a binomial times a trinomial. Just because this has the most things kind of going on all at once, at least in my mind. Some people might say something else is more difficult, but we've got to take, again, everything in this set of parentheses times everything in this set. So this has 2 terms, this has 3. So we've got to take that 2x times that 3x squared, which is 6x to the third. We've got to take that 2x times the other 2x. So that's a 4x squared. And we've got to take that 2x times that -4, which is a -8x. And we've got to take that 1 times the 3x squared. We've got to take that 1 times the 2x. And we've got to take that 1 times the 4. So we have to multiply all of those things together. And now here we do actually have some like terms that we need to combine. So the 6x cubed is by itself, but that 4x squared and that 3x squared can be put together to make 7x squared. Same thing, this -8x and this +2x, we can put together to make a -6x. And then this 4 doesn't have anything to combine with, so it's just 4. But that is your final combined, multiplied answer. So the big takeaways with multiplication. A, don't confuse it with addition. Okay, addition and multiplication, very, very, very different. The process, very, very, very different. It happens all the time. I'll give you the test and one is supposed to be addition and I'll see kids distribute stuff. That's not what we're looking for. Okay. I won't give you anything bigger than this in terms of multiplying. A binomial times a trinomial is as big as it. I would never give you a trinomial times a trinomial. That's crazy. All right, the last thing they can do to kind of trick you with this is just in kind of a notation thing or a way to write something. So if they did 3x minus 4y squared, it's important to know, again, what squared means. You're multiplying this by itself. Most people want to distribute that exponent. They square this term and they square this term and then they're done. That's not the way we do this. Okay, when you square something, okay, 3 squared means 3 times 3. Okay, so if we take this 3x minus 4y squared, what we mean is 3x minus 4y times itself. So we got to distribute again. So 3x times 3x is 9x squared. 3x times negative 4y is a negative 12xy. Negative 4y times 3x is a negative 12xy, or yx, order doesn't matter. And negative 4y times negative 4y is a positive 16y squared. Again, we've got some like terms to combine. So we end up with that. So again, when squaring a binomial, okay, you can't just distribute the exponent. That would give you these two pieces, but you would be missing that middle piece. So remember, when you square something, you're taking it times itself. Then you got to distribute. All right. And last but not least, 5.5. So 5.5 changes gears. And basically 5.5 undoes 5.4. 5.5 is all about factoring. So if multiplication equals distribution, factoring, like I'm using bad grammar here, but is technically undistribution. Okay, we're taking something and breaking it apart. So if I told you to take 3x times 2x plus 1, okay, again, multiplication equals distribution. So that would equal 6x squared plus 3x. So again, multiplication is distribution. Okay, 5.5 is factoring. It's going to be doing the exact opposite. So you're going to start with that 6x squared plus 3x. And we're going to factor out what is called a GCF, or a greatest common factor. Okay, the greatest common factor is the biggest number and variable combination that I can factor or divide out of all of the terms. So if I'm looking at 6x squared and 3x, I can divide out a 3 and I can divide out an x. 6 is divisible by 3 and 3 is divisible by 3. This is the biggest number that I can divide out of these two. Also, variable wise, they both have x's. I can divide out or factor out an x. So this 3x is my greatest common factor. Now, if I actually factor that out or divide it out, then I'm going to be left with something. Okay, 6x to the second divided by 3x is 2x. 3x divided by 3x is 1. So this is the factored form. So again, multiplication, you distribute to everything and get this answer. Factoring, you start with that and then you break it apart. Okay, we divide out or we factor out that greatest common factor. And then we see what's left over once we divide that out. So we basically undistribute. Now, when it comes to finding that greatest common factor, some people are really, really good at this and it happens really easy. They can just see it. Other people kind of struggle. So I'm going to kind of walk you through some kind of step-by-step on how to do it when there's bigger and lots of numbers types of things. For example, if they gave us a 36, x to the fourth, y to the third, plus 24, x, y to the second, minus 12, x to the second, y to the fourth. I don't know. Okay, something like that. Now, some people can just look at these numbers and they're like, oh, the greatest common factor is yada, da, da, da. Other people don't know. They might be able to find one, but they might not be sure if it's the greatest common factor. So I'm going to kind of break this down. If you look at each of those numbers individually. So if I'm just looking at the numbers, 36, 24, and 12. So 36, I'm going to list all of the factors of 36, and I'm going to kind of list them in pairs. Okay, what that means is, so factors are whole numbers that multiply to get 36, like 1 and 36. So 1 times 36 equals 36. These are factors. Okay. 36 is also 2 times 18. So these are factors. It's also 3 times 12 and 4 times 9 and 6 times 6. So all of these numbers are factors of 36. And if you don't know that stuff right off the top of your head, you can do it using your calculator. So start with 36. Obviously, it's going to be divisible by 1. You shouldn't have to punch that one in, but just start dividing. So if I hit 36 divided by 2, I get a whole number. That's a factor. If I hit 36 divided by 3, I get a whole number. That's a factor. If I hit 36 divided by 4, that's a whole number. That's a factor. If I hit 36 divided by 5, it gives me a decimal. Okay, that one doesn't work. 36 divided by 6, that's a whole number. That's a factor. Okay, so you can just use your calculator and straight up do division to see what the factors are. So same thing for 24. Just grab your calculator and start dividing. If we divide by 1, we get 24. If we divide by 2, we get 12. If we divide by 3, we get 8. If we divide by 4, we get 6. Okay, it doesn't divide by 5. And then if we divide by 6, we're already back to, okay, numbers that we already know. So this is all of the factors of 24. 12, okay, get 1 and 12. We get 2 and 6. We get 3 and 4. So you can list all of the factors. Again, the greatest common factor is the biggest one they all have in common. So you can see they all have 1, but that's not the biggest. Also all have 2 or 3 or 4 or 6 or 12. So each of these are common factors, but this one is the greatest common factor. That is the biggest number that I can divide out of these evenly. Now, it did work out that it's, this term was the one I factored out and this term is what I'm going to end up factoring out. That's not always the case. I'll do an example where that's not the case, but in this particular case, 12 is the biggest number that I can divide out of 24 and 36. So my greatest common factor is going to be 12. And the rules for variables and exponents, first off, they all have to have that variable. And then you can factor out the one with the smallest exponents. We've got an x to the fourth, we've got an x to the first, we've got an x to the second. So I can factor out an x to the first. They all have y's. I've got a y to the third, y to the second, and a y to the fourth. The smallest one is y to the second. So this is my greatest common factor. So that's what I'm dividing out. And then what I have left over is just what I get after I divide. So 36 divided by 12 is 3. When you divide exponents, you subtract. So that would be x to the third, y to the first. 24 divided by 12 is 2. X to the first and y to the second, those cancel out. 12 divided by 12 is 1. Subtract your exponents, that's going to be an x, y to the second. So again, this is your properly, completely factored form. Okay, so we got to look at the numbers, find the greatest common factor. We look at the variables. If as long as they all have them, we can factor out the one with the smallest exponent. Okay, then when we figure out what's left over, we divide the big numbers, 36 divided by 12, subtract your exponent. So 4 minus 1 is where the 3 came from. 3 minus 2 is where that y to the first came from. Okay. Similar problem. I just want to make sure we have one where we can't factor out the whole term. So 56, a to the third, b, c to the second, minus 24, a to the fourth, c. Okay, we're looking for the greatest common factor. What is the biggest number that I can divide out of 56 and 24? Now, like I said, some people are really good at this and they can know this without me even moving on, but I'm going to go ahead and write them all down. So 56, the factors are 1 and 56, 2 and 28. Okay, 56 is not divisible by 3, you get a decimal. 56 is, I think it's divisible by 4, you get 4 and 14, I think. It's not divisible by 5, it's not divisible by 6, it is divisible by 7. So these are your factors: 1, 2, 4, 7, 8, 14, 28, and 56. 24, we just did that one. So again, we're looking for the biggest number that they have in common. They're both divisible by 8. Like I said, variables, they both have to have them. We can factor out the smaller of the variable exponents. So we've got an a to the third and a to the fourth. I can factor out an a to the third. All right, the b here, this one does not have a b. So I cannot factor it out. Again, to factor it out, you have to have it in both or all of the terms. Now, they do both have c's, so I can factor out the smaller exponent or that c to the first. And again, we divide. 56 divided by 8 is 7. Subtract your exponents. We get a b, c to the first. Negative 24 divided by 8 is negative 3. Again, subtract your exponents. 1 minus 1 is 0. That's why that c went away. 3 minus 3 is 0. That's why the a went away there. Anyway, this is your completely factored form. Now, there are lots of things they can do to make this trickier. They can give you bigger numbers. They can give you more terms. They can give you more variables. Okay, they can make this tricky in a lot of ways. Another thing that they will do is they will give you a quantity. So, for example, I just kind of want to show it this way. Let's say we had 3xy minus 2y. Okay, I can't factor anything out of 3 and 2 besides 1. This one only has an x, but they both have y's. So I can factor out that y, and that leaves me with 3x minus 2. They can do this number. Okay, in this case, the y was the only term that they had in common, so that was the thing that I could factor out. In the exact same way, if you have a common quantity, just like a singular common variable, so if this grouping, this y plus 1 and this y plus 1 is the same, I can factor out that whole quantity. So if I take 3x, y plus 1s divided by y plus 1, then I'm left with a 3x. If I've got -2, y plus 1s, and I divide out that y plus 1, then I'm just left with 3x minus 2. So I can factor a single variable out, or I can factor out an entire quantity. It's all the same thing. Which leads me to the last thing they're going to have us do in this section, and that is to call factor by grouping. So they're going to give us something, some polynomial with 4 terms. Actually, I messed this one up. I'm going to change this real quick. So sorry, I'm going to do x to the third plus 3x squared plus 5x plus 15. I'll explain why I changed that in just a second, but I'm going to change this one. I'll come back and talk about this one, but I didn't realize in what I was doing that I made that one step harder than I wanted to. Anyway, if we look at this particular problem, there's no greatest common factor that we can see right away. Okay. If you look at the big numbers in front, this is a 1, so it's obviously not going to be divisible by anything but 1. And if we look at the variables, this one doesn't have an x, so there's not an obvious greatest common factor. So you might be tempted to think that, okay, this one's prime, or the only greatest common factor is 1. But there's a strategy we can use called grouping. So when you have 4 terms, we're going to try and group this. So I'm just going to look at this first group of numbers, and then I'm going to look at this second group of numbers. So if I ignore the 5x plus 15, and if I just look at this x cubed plus 3x squared, I can factor an x squared out, and that would leave me with x plus 3. If I look at just this group, so if I ignore that one, if I just look at the 5x and the 15, I can factor out a 5, which leaves me with x plus 3. And then now this looks like the last problem I just did. If you have a quantity that's the same, that's my greatest common factor. Okay, we couldn't see it from our original problem, but in one step, if we look at this group and we look at this group, oh, wait a minute. Okay, my greatest common factor is x plus 3. I can divide that out of both of those. And if I divide that x plus 3 out, I'm left with x squared. And if I divide that x plus 3 out, I'm left with plus 5. So this is my correctly factored form. So again, factoring by grouping works if there are 4 terms. That's pretty much the only time you're going to use this. Can't read my own handwriting. Okay. So again, we're looking at 4 terms. I'm also going to look for a greatest common factor first. In this case, I can't divide any number out of 6 and 5 and 12 and 10 besides 1. Same thing. This one has an X, this one has a Y. Okay, they don't all have the same variable. This one doesn't have an X, this one doesn't have a Y. So there's no obvious greatest common factor. So again, I'm going to look at the groups. If I look at this first group, I can take out an X. They both have X's. If I factor out an X, I'm left with 6X plus 5Y. If I look at this group, I can factor out a 2. That leaves me with 6X plus 5Y. And if my parentheses are the same, that's my greatest common factor. And then I'm left with what is on the outside. So again, that is my properly factored polynomial. All right, like I said, I do want to go back and look at that first problem, the one that I kind of messed up. I'm going to change it up just a little bit, but I want to at least look at that one. So let's say I need to factor x to the 4th plus 3x to the 3rd. I'm going to change it up just a little bit, minus 5x squared minus 15x. All right, so like I said, the first thing you always want to look for is a greatest common factor. And again, if we look at the big numbers, the coefficients, this one's a 1, nothing else is going to be divisible by anything but 1, so we can't factor anything out but a 1, that doesn't change anything. But now, if you look at your variables, they all have x's. I can factor out an x. Now, I still have 4 terms. I still want to look and see if I can factor this by grouping. So again, I can factor out an x squared, leaves me with x plus 3. Now, when dealing with negatives, okay, I've got a negative 5x and a negative 15. If they're both negative, I can factor out a negative 5. Remember, when you divide, negative divided by a negative is a positive. Negative divided by a negative is a positive. So again, that x plus 3 is my greatest common factor, and then I'm left with that x squared minus 5. But don't fall into the trap. Don't forget that we started with our greatest common factor of x, which is still one of the factors. So that's part of your final factored form. All right, we covered a lot of ground. So we covered 3 sections. We covered 5.3, 5.4, and 5.5. 5.3 and 5.4 were very similar, but different, easy to confuse. 5.5 started basically doing the opposite of 5.4, undistribution. So we're taking a polynomial and then breaking it up. The rest of the unit's going to kind of go along with more of the factoring thing. We're just going to give you some more strategies and some different type of problems to factor, but that's going to be a different lesson for a different day. As far as that goes, that's basically all I'm going to cover tonight. I'm going to be here the whole class time. So if you want to stick around and you've got questions to ask, feel free, ask all the questions that you need. But if you don't have any questions, you can have the rest of this time to go work on your homework, or you can do whatever you need to do. So next week, we do have a lesson. We will cover the last 3 sections. I believe it's 5.6, 5.7, and 5.8. And that'll be the last thing before we test the following week. Again, make sure you're staying on top of your homework. Those due dates are kind of set in stone, more or less. I can't affect them a whole lot. So make sure you're getting your homework done. A lot of these sections have a lot of problems. You do not want to leave all of the homework to the end. You're just going to bury yourself. Do it a little bit at a time. If you want to go back and look at it to review for the test, that's great, but make sure you're staying on top of your homework. It's extremely important. Okay, throwing away a couple of homework, even if you can just do part of it, some percentage is better than a 0. Okay, get points. Points are good. Math is all about it. Grades are all about accumulating points. Get as many points as you can get. So do your homework. So that's, like I said, that's all I got. If you're done, you're free to go. See you guys next week. Like I said, if you have questions, stick around, ask them. Otherwise, I'll see you later.